Hello guys, my name is Lazar and today we're going to be doing another LeetCode problem. And this one's called Reducing Dishes and it's a LeetCode hard. A chef has collected data on the satisfaction level of his N dishes. Chef can cook any dish in 1 unit of time. Like time coefficient of a dish is defined as the time taken to cook that dish, including previous dishes multiplied by its satisfaction level. So time it took to cook that dish times the satisfaction level of that dish. Return the maximum sum of like time coefficient that the chef can obtain after dishes preparation. Dishes can be prepared in any order. The chef can discard some dishes to get his maximum value. So for here we get our input array, which is called satisfaction, and it consists of -1, -8, 0, 5, and then -9. Now we want to get this maximum satisfaction value, this maximum like time coefficient value. And we can do this by first cooking the -1 at time 1. So that's -1 times 1. This is the satisfaction, and this is the time that he cooked the dish at. Plus the second dish that the chef decided to cook, which to get this maximum value would be 0. So 0 is the satisfaction level, 2 is the time he cooked it at. So far we have -1 times 1 plus 0 times 2, which is just straight up -1. And then the third dish that he's going to decide to cook is the 5. That is a dish has a satisfaction level of 5. And he's going to cook this at time 3. So if we sum this all up, we'll get -1 times 1 plus 0 times 2 plus 5 times 3, which is going to be equal to -1 plus 15, which results in 14. This is the maximum he can get for this example. Now there's three other examples here. They don't go as detailed in the explanation, but there's no need to worry about that. We're actually going to focus on this first example and break it down until we really understand what are we trying to solve and how we can figure out an algorithm for this problem. So let's take this first example, -1, -8, 0, 5, -9, and it's actually ready here so we can work with it. -1, -8, 0, 5, -9, just to make sure. Yeah, 0, 5, -9. Perfect. So one thing that I want you to agree with me on is that he's always going to want to cook the largest positive value last. The reason he wants to do this is if he cooks the largest positive value last, then he'll get the largest positive satisfaction level multiplied by the largest time interval possible. So in this case, I believe it was 3. And then he's going to want to do this for every single positive in order. So first, since 5 is the largest, he's going to want to cook this last. In this case, it was 3. And then he got the next largest positive, which was 0, multiplied by 2. And then he decided that it was worthwhile cooking a dish that had a negative satisfaction level, just because if he included that negative dish, then he could have upped the time it took to cook the positive dishes, which would overall result in a larger positive or in a larger like time coefficient. Yeah, like time coefficient. So let's break this down just a bit more to make sure everyone understands what I'm talking about. So first off, like I said, we already know we want to cook the largest positive last. Now, how can we figure this out instantly? Well, as it turns out, it's be pretty helpful if we were to sort this array. So I'm just going to go ahead and sort it right here. We have -9, -8, -1, 0, whoops, 0, and then 5. So this is the exact same array, but just sorted. Now, the chef can do a couple of things. he can cook just the largest positive for a value of 1, and he'll get a like time coefficient of just 5. Or he could also include the 0, cook the 0 first at time 1, then cook the 5 at time 2, and here he'll get a value of 10, a like time coefficient of 10. So it's worthwhile to go ahead and cook that dish at a satisfaction level of 0. Now he's going to wonder and say, well, what happens if I include a negative one, a negative satisfaction level dish? Is it worthwhile? Well, let's go ahead and try that out. Let's see. So let's say I cook this -1 dish at time 1. I cook this satisfaction level 0 at time 2. And then this satisfaction level 5 dish at time 3. This will give us -1 plus 15, which will give us 14. So far, we've been strictly increasing our like time coefficient. If this is the case, well, let's try another negative satisfaction level dish. Let's try -8. Let's see if we should cook this one or not. So we cook -8 at 1, then -1 at 2, then 0 at 3, and then 5 at 4. This will give us -8 plus -2 plus 20. And then this is going to result in 10. Whoops. Because -8 plus -2 would be -10. -10 plus 20 will just give us that 10. So as you can see, we actually dropped our like time coefficient dropped from 14 to 10 if we go ahead and include the -8 satisfaction dish. Therefore, it's not worth it. Now, what's one pattern that we notice from this? Well, we notice that every time we add another dish, we're basically taking the previous sum and multiplying, just adding one more. So what does this mean? Well, this 5 times 1 is just equal to 5. Then this 0 times 1 plus 5 times 2 is equal to 0 plus 5 plus 5. As you see, one of these previous 5s is actually coming from the last one. So we're adding one more time. Now let's see. I'm going to erase this last one since it didn't really help. Let's see if this pattern continues. I'm going to go ahead and draw this right here. This -1, we're just adding once. So it's -1 plus 0 plus 0, then plus 5 plus 5 plus 5. Well, these two 5s came from over here, the last one. This first 0 also came from right here. So we're adding the -1, the new value we're currently on, then also adding a 0 and 5, which is the previous values without taking into account the multiplication. And this is a big part of the pattern, that every time we're adding a negative, we're also going to be adding the sum of the positives. So let's continue and let's go with the -8. Let's say we did include the -8. Well, the -8 would have resulted in -8 plus -1 plus -1 plus 0 plus 0 plus 0 plus 5 plus 5 plus 5 plus 5. This first three 5s came from the one before it. These first zeros, this first two zeros, also came from the one before it. And this -1 also came from the one before it. So we're taking these values, adding them to our previous, and then adding the -8. So let's see if we get the same answer. So we already did all these computation previously. So it's basically saying -8 plus this -1 right here, plus 0, plus 5, and then plus the 14. That 14 is coming from these repeated numbers. This will be turned to -9. -9 plus 5 would be -4. Then 10 plus -4 would just be 10, and it's the exact same value as before. And this actually helps a ton. Now, why does this help? Well, we can actually figure out this sum from the beginning because we're always going to want to take the positive numbers. It's a positive satisfaction level, so why not take it? It would not hurt us at all. So if we always take the positive numbers, we just have to keep track of the sum of these positive numbers. So for example, these positive numbers right here result in, let me erase this. Okay, results in 10. Yeah, you know what? I'll leave it like this. So that resulted in 10. But the numbers that we used to get this was 0 plus 5. And that's just 5. So for every negative number we're going to add, we need to make sure that the addition of that negative number will be less than 5. Because we want some positive outcome. If adding this negative number is greater than 5, then it's going to be doing more damage. It's going to be doing more damage than good. We want some sort of benefit of adding this negative number. So why exactly did we add the -1? Well, if we were to add the -1, we would have been adding 5 to our previous answer, which would have given us 14. If we decide to take this -8, then we're basically saying we'll be taking the -8 and all the previous negatives we've seen, which in this case is just -1. Now this will give us a total of a -9. This -9, keep in mind that this is without taking into account the fact that this -1 is actually going to be multiplied by 2. So this just simple addition of the negatives we're considering, since this -9 is so negative that it's worse than our benefit factor, we know that we want to stop. And we do not want to cook the -8. Because at this point, if we include the -8, we'll be doing a damage of -9. So let's actually write this out. So let's write this out. -9 plus the 5 will be suffering, or our value will be going down by -4. This -4 plus the previous we saw, which was 14, whoops, is what's going to drop us to that 10 if we were to take the -8. And this 10 might remind you of the actual value that we calculated the long way in the beginning or previously. So this calculation right here is very important, and this will tell us when to stop considering more negative numbers. And this is really all the information we want to know. We want to always take the positive numbers. What is the sum of the positive numbers we're taking? In this case, this is 0 plus 5. That will be our benefit factor if we were to include negative numbers. and then go up to as many negative numbers where the sum of those negative numbers, the addition of the sum of those negative numbers plus the benefit factor is greater than 0. So here, -1 is greater than 5. -8 plus -1, is that greater than 5? It is not. So that's when we stop. So now that we know the logic, or we know the main idea and the little trick to solving this problem, let's actually code it out. Alright, so I already had it, so I set to delete it. Anyways, let's remember that we said that we had to sort it because we want to take all the largest positive last. So let's just do that. So I'm sorting it, and now we want to handle the positive numbers only. So that summation of the positive numbers, let's call that positive sum, set it equal to 0. The positive numbers we've seen, also set that to 0. And I'll explain why I need this variable later on. And our answer, let's also set that to 0. Now for every number in satisfaction, if that number is positive, then we want to increase our positive sum by just adding that satisfaction level, increase the positive numbers we've seen, and then our answer will be the summation of that. At the time we saw that, you know what, let's actually change the time. At the time we saw that dish, or that dish times the satisfaction of that dish. And this is only for positive numbers. Now we want to handle the negative numbers, and we want to do something pretty similar. We want the negation, sorry, not we want the summation of all those negative numbers. So let's call that, let's make a variable for that. We want to know how many of those we've seen. Set that equal to 0. I'll explain later on why I need this. And we kind of, how we had an answer here for the positives, we're going to want to do something pretty similar for the negatives. Now let's go through this list again, but let's go in reverse. The reason we're going to reverse is because since we sorted it, we first want to look at the smallest negatives. So if we go reverse, we'll be achieving that. We'll be considering the smallest negative satisfaction level dish. Now, if this value is negative, we want to do our logic. So first, let's compute the total, which is the summation of all the negative numbers we've seen so far. This total is going to be equal to the previous negative number summation plus the current one we're on. Now, if the positive sum, which is our benefit factor, plus the total of all these negatives, if this is greater than 0, then we actually want to consider this negative satisfaction dish. And to consider it, what we want to do is we want to increase the negative answer by adding total to it. We also want to increase the summation of all the negative numbers by adding this current one we've seen. And let's just increase the count of negative numbers we've seen as well. Else, if the summation of the negative numbers we've seen to this point plus the benefit factor of all the positive numbers, if it's negative, then we know we do not want to consider this negative number, and we can just break. Finally, at the end, what we want to return is the answer right here from all the positives, take into account the time that we're seen at, plus the summation of those positives times the amount of negative numbers we took. Because remember, this in this case, positive sum is 5, and we're multiplied by the amount of negative numbers, because every time we're adding a negative number, or we're cooking a dish that has a negative satisfaction level, we're adding this positive benefit factor. So that's why we're doing this arithmetic right here. And we also want to add the negative answer. This negative answer basically represents the negative 1 times 1, or if we were taking the 8, it would represent the negative 8 times 1 plus the negative 1 times 2. That's being handled right here. So now let's run this. Make sure there's no errors. Okay, I believe I did make one small error. Let's see where it is. Ah, yes. And here, instead of answer, it should be the amount of negative numbers we've seen. So let's run it one more time. There we go. And now let's submit it. And it gets accepted. Perfect. So the time complexity of this is to be big O n log n. And the reason for that is because we're sorting it in the beginning. Now, although these are of n time complexity, this one awaits it. So the big O complexity is n log n. Now, if this sorting algorithm, this sorting function, I believe is in place. So space complexity is constant because we're only using variables. We're not creating an array that changes depending on the size of our input. Now, this was a really cool way of doing it. It's kind of a greedy way. There is some DP way of doing this where you either take this dish or you don't, and you see what's your maximum you can get. But hopefully you guys were able to follow along. I know it was pretty hard to wrap our heads around, but just keep at it and convince yourself that it does work. Try to do a couple edge cases till you fully understand why this is correct. But other than that, I hope you guys enjoyed, and thank you for watching.